Alright, so today I'm going to be talking about the alternating series test. Alright, an alternating series is a series where each term is positive to negative, and so on. It usually has one of the following factors within the general term. It's like -1 to the n is probably the most common, but I've also seen cosine of pi times n or sine of pi over 2 times n, or maybe instead of -1 there's like a constant mixed in there to the nth power. Right? This alternating series test says that the series must be alternating and the absolute value of the terms must be decreasing, and if the terms are decreasing, the series converges. Okay, so let's talk about this a little bit for a minute, because there is something called the absolute convergence test, where you have a series that has negative terms and positive terms on it. It might be alternating, it might not be alternating, but what you basically do with that test is you take the absolute value of the entire series, you get rid of any negatives, and if the positive series converges, then the alternating one, or the one with the negative terms in it, is going to converge as well. And we call that absolute convergence, meaning it converges regardless of the negatives. It converges absolutely, and everything's fine. This alternating series test is basically, if that test fails, if that absolute convergence fails, we go to this other test that says, you know something? If these terms are alternating, so if we think back to steps, and I'm going to use the following series. So 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6, and so on. Okay, this is the alternating harmonic series, right? Now we know from the last one that the harmonic series by the integral test diverges. But if we think about these terms as steps, right? So we've got this number line here. Let's say this is 0 and this is 1. The first term says take 1 step forward. The second term says take a 1/2 of a step back. The third term says take a 1/3 of a step forward. And then we're going to take a 1/4 of a step back. And so you see that how every step we do, we're never going as far as the previous step, right? Like this 4th step right here goes backwards, but it doesn't go backwards past where I started before the 3rd step, right? The 3rd step started at 1/2 and took me to the right. My 4th step goes backwards, but it doesn't get as far as 1/2. The next step is going to go forward, but it's not going to get as far as this one here. And so each step, because they are smaller and smaller and smaller and smaller, we're going to be moving towards some value. We are going to end up converging. All right? This minus 1/6 is not going to get me like further than that starting point. And the next plus 1/7 is not going to get me further than that. We're going to constantly be stepping a smaller step back, and then a smaller step forward, and then a smaller step back, and so on. And it's going to converge, but it's only converging because it is alternating. I couldn't take the absolute value of this, which would just give me the harmonic series, and converge. I know that one diverges. So we say that this one converges only because it's alternating. It has what we call conditional convergence. It only matters that, one, each term is getting smaller when you take the absolute value of it, and it is alternating. we say it converges conditionally, just like this one does. All right? And so that's the alternating convergence test. Sometimes we'll go even as far to say that the maximum possible error, that is, if you add up, let's say, the first 8 terms here, we're going to be close to what the value is that it converges. How close? Well, the worst off we could be is 1/8. Right? Because I know 1/8 is going to step over the convergence, but it's not going to step as far as the next term, or the previous term. So that 1/8 is maximum what we're going to be off. You want to get closer, go out a few more terms and look at the next one, and that's the max that you're going to possibly be off. All right, so that's the alternate series error bound is always the next term. So if you looked at the partial sum, let's say the fifth partial sum, its error with the actual series, that is, if you subtract it, has got to be less than or equal to the 6th term. Okay? And that would be the alternating series error bound. The difference between the actual sum of the series and the 5th partial sum is going to be the 6th term. Usually we wrap it with absolute values as well. All right? There we go. Right? So that's the maximum it can be off. All right, guys? That's the lesson for today. Take care.